Good morning. This is Unit 2, Day 4 notes, and these are really important day. It is how to find real zeros of a polynomial. So the division algorithm, if you have d of x divided by q of x plus r of x, then f of x and d of x are polynomials. As long as d of x does not equal 0, the numerator is, or this is not 0. The degree of d of x is less than the degree of f of x. If r equals 0, then d of x evenly divides into f of x, and the quotient will be q of x. I know that's a lot. Don't worry about it. I'll explain what this means. The intermediate value theorem, I think we kind of talked about this last time, is an existence theorem which states that a continuous function on an interval cannot skip values. So if there's these three conditions will hold that if there is at least one number c in a through b, so that f of c equals k, as long as it's continuous and f of a doesn't equal b, then and k is any number in between f of a and f of b. So if my y values go all the way up to f of a, okay, so all the way up to here, and all the way down to f at b, so all the way down to here, then there has to be a k in between there. There has to be a number in between there, and this is going to be k, and this is going to be f at c will give us k. That's all it states. We talked about this before. The long division using synthetic division. This is something that we went over a lot in Algebra 2. We need to make sure we know this. Divide using long division. So we have x minus 4 goes into 5x squared minus 17x minus 12. We just wrote it down. What I'm going to do is start with the first term, x. What do I have to multiply x by to get 5x squared? I need to multiply it by a 5. I'm missing a 5. And I'm missing an x. 5x times x is 5x squared. Perfect. That's what we're doing. That's what we need. Now I kind of like distribute it to both. 5x times x is 5x squared. 5x times negative 4, 5 times 4 is 20, so this is negative 20, right? X. That's an x here. Alright, now what I'm doing is I'm subtracting. We're going to minus it. 5 minus 5 is 0, that's what we did it. That's what we want. Now, negative 17x minus a negative 20x is going to be a positive 3x. And then what we do is we just bring down the next number, which is negative 12. And I'm going to do the same thing. X times what will give us a 3x? Well, you just have to multiply it by 3 this time. 3, and then distribute it. Distribute it. 3 times x is 3x. That's why we did it. That's what we want. 3 times negative 4 is negative 12. But we are subtracting. Not adding. We are subtracting. 3 minus 3 is 0. Negative 12 minus a negative 12 is 0. So the remainder is 0. That means it does go in there. It does divide. X minus 4 does go into 5x squared minus 17x minus 12 evenly. So it's a factor. That means that the factors, if I wanted to factor this, it would be x minus 4 and then whatever we have on top, which is times 5x plus 3. And then we can say equals 0. Factor times factor equals 0. Alrighty, let's try synthetic division. The biggest thing what you have to remember is that we have to change the sign. We can only use synthetic division if there's no number in front of the x. And if it's x minus 4, we have to change the sign. We only put 4 over here. If it's x plus 4, then we put a negative 4 over here, okay? So I wrote it down. This is a 0. If it divides evenly, this is a 0, okay? We'll see. Now, then we like leave some space down here, but then we write in just the coefficients. I have a 5, I have a negative 17, and a negative 12. Okay? I'm going to try that using synthetic division. What we do always is we bring down the first number. This is going to be brought down, and then we just multiply. 5 times 20, or 5 times 4 is 20, and then we just add. Since we're changing the sign, we don't have to subtract again. That's why we're changing the sign, so that we could just add. 17 plus 20 is 3. Sorry, negative 17 plus 20 is 3. 3 times 4 is 12, but negative 12 plus 12 is 0. Perfect. And then we just subtract exponent. So what we do is we just write down the 5, and if it was x squared, now it's just x to the first power, 2 minus 1. And then plus 3. We just go down 1. That's it. This is a factor. Also, of course, the x minus 4 is a factor, equals 0. Alrighty, let's just keep going. The remainder and factor theorem, this is pretty cool. If we have a polynomial divided by something like x minus k, or k is a number, the remainder, r equals f at k, is on the graph. That's what it's trying to say. This is going to be on the graph. So I'm going to show you what that means on this one. Okay? It says use the remainder theorem to evaluate this when x equals 5. So we're going to say x equals 5. This one is already solved for you. The factor would be x minus 5 equals 0. Okay? But we change the sign. We move it over. We change the sign. My sign is 5 now. Put it in the box. Draw a line underneath it. Put in the coefficients. Make sure it's in descending order. And if you're skipping one, like we don't have an x maybe, then we just put a 0 as a placeholder. You have to put in the placeholder. This one, there's no placeholder. So we have a 4, and then the next term is a negative 10, and then the next term it's a negative 21. Make sure it's in descending order, standard form. Remember, we always bring down the first term, that's a 4, and then we multiply. 4 times 5 is 20, and then we add negative 10 plus 20 is positive 10, and we multiply. 10 times 5 is 50. Negative 21 plus a 50 is I think it's 29. Try it out, make sure, okay? But this is my remainder. Usually usually a 0. We want it to be 0. But what this means, we use this number right here, and we're saying f at that number, so f at 5 is on my graph. And the y value is going to be the remainder, 29. That's pretty cool. So this means that 5, 29 is a point on the graph. Well, it's f of x. We'll call it f of x. Okay? I want you guys to try this one. Okay. Alright, we're going to try the remainder theorem. We're going to verify that x plus 3 and x minus 2 are indeed factors of this. I think this is fun. Let's try it. So it's x plus 3. So what I'm actually going to do is I'm going to pull out a negative 3. And I draw the line, put it in the box first, and then draw the line. And then I'm going to write down the coefficients. It's already in descending order. Be careful when you take a quiz. Make sure it's in descending order or a test. So I have a 3, and then 2, and negative 19, and positive 6. So it's an extra term. Remember, we always bring down the first term, 3, and then we multiply times negative 3 is negative 9. 2 minus 9 is negative 7. Negative 7 times a negative 3 is actually a negative or a positive 21. Well, 21 minus 19 is 2. 2 times negative 3 is negative 6. Ooh, that's awesome, because that remainder is going to be 0. Awesome. So that is a factor, because my remainder is 0. I'm going to, usually I would just be lazy and like use this as a new coefficients and then write the 2 right here and then do it again. But I'm going to be not lazy right now. I'm going to bring this over. This is x minus 2, so I'm actually going to put a positive 2, remember? Put it in a little box. And then I'm just going to rewrite what is left over, because if negative 3 is a factor of this, then and 2 is a factor of this, then or of this, then I can also use what's left over. So I have a 3, I have a negative 7, and a 2. That's all I have. Remember, I bring down the 3, bring down the first one. 3 times 2 is 6. Negative 7 times, or plus 6 is negative 1. Times 2 is negative 2. Ooh, that remainder is also 0. So I'm verifying, since our remainder is 0, that this is indeed a factor. Now what's left over is 3x minus 1. Okay? And what I can do is I can find the other 0. Find all the zeros. This is just a straight line. I can solve this. So we have, to add the 1, 3x equals 1, divide by 3, x equals 1/3. Now all of the zeros, my zeros of f of x, are, I have to remember these. You have to remember them. When I move the 3, when I set this equal to 0 and I move the 3 over, it's actually going to be a negative number. So negative 3. This one is going to be positive 2 and positive 1/3. Those are my solutions, or my zeros, or my x-intercepts. There's a lot of names for those. Use the remainder in synthetic division. This is basically what I just went over. The remainder obtained in synthetic division provides the following. The remainder gives the value of f at x equals k. We just went over this. F at k equals r. If r equals 0, then x minus k is a factor. So if we don't have a remainder, then that's a factor. If r equals 0, then the k0 is going to be an x-intercept, or a 0, or a solution. There's a lot of names for that. The rational zero theorem, this is very, very, very important. Put some stars by it. If a polynomial of degree n plus 1 in descending order, then it's possible to make an organized list of potential numbers to aid in finding the zeros of the function. So how do we know which numbers to divide out and find out if it is a factor? What if they don't give it to us? Well, there is actually a way to find them out. It is the constant term, so the factors of the constant term divided by the factors of the leading coefficient. The constant term in this one would be like negative 6 or 6. Okay, so this would be the p. Can you guys underline it? Right, p. All right, the leading coefficient is the q. So this is q. Okay. So the factors of q, let me just write it. P equals 6. So the factors of 6 are 1 times 6 plus or minus 1 plus or minus 6, what else? 2 times 3. So plus or minus 2 plus or minus 3. That's a lot, actually. The factors of, the q is 1. So the factors of 1 is plus or minus 1. That's it. Very nice. So what we can do is we do p divided by q. So those are going to be all of these numbers divided by 1 is just these numbers. Plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So these are all potentials. Now, we have to try them, basically, and what you can do actually is you can plug them into the regular equation, and if that gives you 0, then we know it's a factor. But I'm going to try one and use synthetic division because it's shorter and find out if it is a 0. Okay? So let's find the rational zeros. So we have to find the actual zeros. Alright, well, let's try -1. Okay? And I'm going to write down the coefficients. I have a 1, a -7, and a -6. Draw a line underneath it. Bring down the 1. 1 times -1 is -1. -7 plus a -1 is negative. Oh, I forgot about the 0 right here. I knew something that didn't look right. Okay, so there is no x squared. We have to have a placeholder. So I have to have a 0. And then I can put -7 and -6, right? So -1 times 1 is -1. 0 plus -1 is -1. Times -1 is +1. -7 plus 1 is -6. Times -1 is +6. Very nice. And this is 0. Very nice. So since the remainder is 0, this is a factor. So I know that x equals -1 is a 0. Okay. The rest, this is actually just a quadratic. This one was cubed. So 1 less would be x squared minus x and then -6. And I can actually just factor this. You can use synthetic division again, like try another and find out if it is a factor, but this would be easier for me to just factor by hand. So this is x squared. I know that x times x gives me x squared. The factors of 6 are 1 and 6, but that difference is not 1. It's got to be 3 and 2. 6 is negative, so one's negative and one's positive. But this number right here in front of the x, this is negative. It's a -1. So I know the bigger one has to be negative. So the 3 has to be negative. This is positive. That's equal to 0. Now when I set each term equal to 0, I know that x is going to equal to +3 and x is going to be equal to -2. And those were all factors, or potential factors. So my zeros are, I'm going to just do this, -1, -2, should have put -2 first, and then 3. That's it. These are all zeros. Box around it. Alright guys, I'm going to help you just get this one started. Please try these. Let's find the list of all the possible p's are going to be, is -1. The factors of 1 are plus or minus 1. Q is 2. The factors of 2 are plus or minus 1 and plus or minus 2. So it's P over Q, so that's plus or minus 1 and plus or minus 1 over 1, 1 over 1, 1 over 2. Half. Ooh, this is a fraction. Okay. So I would try the whole number first. I would try 1 and -1. Let's try -1. Put it in the box. Write down my terms, my coefficients. We have a 2 and a 3. Don't forget to include the 0. We don't have a term with just an x. We have a x cubed, x squared. We don't have a term with just x, right? So this is a 0, and then we have a -1. Okay. Remember to bring down the 2 and then multiply it. And tell me what you get. If you guys have any questions, please let me know. Have a wonderful day.